All right, as we get started today, have your books out open at page 337. You had to do numbers 1 through 5 and 7 through 11 for homework. We did not do number 6, basically, the constructing the line graph, because we were talking about that today. We did everything else on this page. Before we get started, we've talked about several different types of graphs. We want to make sure we keep these things straight. Which type of graph is used to track changes over time? Which graph is used to track change over time? Luciana? The line graph. Which one is used to compare data and show groupings within different types of data? Show groupings within different types of data while still comparing that data. Joel? No?
Histogram?
No?
Bar graph.
Specifically?
Stacked bar
The
graph.
stacked bar graph shows comparisons, but also shows groupings within those comparisons. So it kind of does a couple different things at once. Which graph is used to compare parts to the whole? Which one is used to compare parts to the whole? Back to Joel?
Circle graph.
That's the circle graph. Which one is used to compare data that's related but independent? Compare data that's related but independent.
Bar graph.
The bar graph. Which one groups the data into classes and then compares the classes or shows frequency within classes or groups of data? Which one is that? Kirsten?
Histogram?
The histogram. And so we've been looking at all these different graphs. Now with the bar graphs, the line graphs, we see a line graph on page 337. Jay's Barbershop gets different customers throughout the day, kind of up and down, that kind of thing. What type of line graph is that there on page 337? Specifically, what type of line graph? We talked about 3 different types. Corey?
Broken line.
A broken line graph. Good. Now, if we wanted to show a gradual, continuous change throughout the day or something like that, we wouldn't use a broken line graph class. We'd use a curved line graph. And if there was just a consistent progression that never changed, just steady progression, we would use class A, straight line graph. But here, in this class, we're focusing on the broken line graphs, and that's what we have there. At the top of the graph, as there should be at the top of every graph, telling us what this data is even talking about, we have what, Ben?
A line graph?
At the top of the line graph, telling us what on earth this graph is talking about, we have
Title.
the chart title at the top. Very good. Now, up the side, we have numbers. What are the numbers up the side called, class?
Scale.
The scale, right? The scale on a line graph is always going to be vertical. And what do those numbers mean? 4, 6, 8, 10. What are those numbers even talking about, Joel?
The customer.
The number of customers. That axis title tells us it's talking about customers. Now, the lines all the way across that are numbered, class, those are called the major grid lines. And then there's the little bit lighter ones that aren't numbered. Those are called the minor grid lines. It's important to know how big each of the minor grid lines is, or the value of each minor grid line. On this graph, what is the value of each minor grid line, Bryson?
2. No, 1.
1. The major grid lines are 2, so that means the minor grid lines are going to be 1. Notice, by the way, you don't have to start a line graph at 0. Bar graphs, I said you need to start them at 0. Line graphs don't necessarily have to start at 0. And then across the bottom, because line graphs show changes over time, your labels are generally going to be some type of time. Either hours throughout the day, days of the week, weeks of the year, months of the year, different years themselves. But we're going to have some kind of time relationship going across the bottom. Here, it's all within a single day. Let's look at the questions that they ask about our line graph. Number 1, when did they have the most customers that day? What time did the most customers come in? Elaine?
5 p.m.
At 5 p.m. When they get off work and they come, and that's one very long hair on that guy. He's looking up like it's all about to be gone. Anyway, all one of it. Anyway, what time did they have the fewest customers? When did they have the fewest customers? Kirsten?
8 a.m.
8 a.m. I'm surprised they're even open at 8 a.m., but nobody at 8 a.m. is wanting a haircut. They're still sleeping or they're going to work. At what time did they have exactly 11 customers? At what time or hour of the day did they have exactly 11 customers, Bryson?
10 a.m.
At 10 a.m. That thing's right at 11. Which 2 hours did we see the biggest decrease in customers? Between what 2 hours did we see the biggest drop in customer clientele, Corey?
1 p.m. to 2 p.m.
Yeah, from 1 to 2. So notice there's a few customers throughout the morning, and then all of a sudden it really jumps up right around what time?
3? No. 5?
It jumps up all of a sudden. So early morning, it's kind of slow, and then it starts to jump up around 11, right? Why do you think maybe the jump in customers around 11? Ben?
Lunchtime.
And so maybe some people coming in for a haircut on their lunch break. Maybe that's what's going on. But then around 1 p.m., all the lunch breaks are over, right? And so there's the big drop off. So that's probably kind of what it is. And then people getting off work, we see a jump again throughout the day. And we already asked number 5, what does that vertical scale show, class? The number of customers. Questions on how to read that line graph. Michael?
I was just gonna ask, do you think he can cut that many people at once, or does he have workers?
Well, it kind of shows when it says 1 o'clock, it's really kind of meaning within that 1 o'clock hour. He might have other barbers that work with him, so it's Jay's barbershop, but Jay may have a few different employees. I don't know. I assume he probably has some employees because that's a lot of people to be cutting in 1 hour. I mean, 22 customers at the 5 o'clock hour. Now, he's got to have a few other barbers with him, surely. Let's drop down to numbers 7 through 11. What kind of graph are we using here on 7 through 11, Luciana?
A bar graph.
And what is this bar graph even talking about, Jalen? Soccer goals scored. So we have 5 different guys, and how many soccer goals did they score, presumably during the season? Surely this isn't in one game, or that's a really bad game for their opponent. Okay, certainly it's over the course of a season. And notice, by the way, that the bars continually get smaller. They have ranked the data here, but inverse ranked it. They did biggest to smallest. They put it in order. And who had the most soccer goals? Question number 7. Joel? Clearly Nicholas. Who scored exactly 10 goals that season, Michael? Johnny. What's the total number of goals scored for the whole team? If these are the only 5 guys that scored goals, there we go, get it out. How many goals did the team score that season, Jalen? 47 goals. Who's the median scorer for this team, Kirsten? Johnny. And how many did he score?
10.
He scored 10. What's the range for this data, Elaine? 9. The biggest minus the smallest. Do you see we could still use a little of the mean, median? There's not a mode, obviously, here, but yeah, so we can still use some of those terms. I guess technically, if we look up at the line graph, there is a mode. What's the mode? Looking at the line graph, the number of customers that happened most often. There was one number of customers in one of their hours that happened the most often. Ben?
1.
No. Corey? 20. There were 20 customers at 1, and there were 20 customers at 6. That's the only time anything happened more than once. I mean, it's kind of a stretch to say the mode, but whatever. All right, questions on this? Questions on these graphs? Look across the page, if you would, please. And there's a whole group of problems in the review section here. And of course, we start off with, they've got a stem and leaf plot, which we didn't really talk about. We got a box and whisker plot they want you to make or finish. 24, we didn't really talk about that. But in order to use a circle graph on 25, which we do know how to do circle graphs, in order to do the histogram, which we know how to do those for 26, we have to know the numbers. And they gave us all the numbers here for different students' test scores. But they gave us the numbers in the stem and leaf plot. Look at the stem and leaf plot, if you would, please, with me. And there's some blank space beside the stem and leaf plot. I want you to use that blank space to write down these numbers. They put the scores in order from least to greatest. And the lowest score in the class, does anyone want to look at that stem and leaf plot and see if you can figure out the worst grade in the class? Ben?
58.
58. What's the next worst grade, Ben?
59.
59. Do y'all see where we got the numbers 58 and 59 from? The stem 5 has 2 leaves with it, 8 and 9. That means numbers 58 and 59. How many students would have scored in the 60s, class? 3 of them. And their grades were, say them with me, 63, 66, and 69. Do you see how to read a 7-leaf plot? How many students would have made a C? They would have scored in the 70s.
8.
8 students scored in the 70s. Let's write this down. So in the 50s, we have 2. In the 60s, we have 3. I'm just going to say 70s, we have 8. 71, 73, 75, 76, 77, 77, 78, 79. But there's 8 students in the 70s. How many students scored in the 80s? How many students scored in the 80s? Good. Several of you already figured that out. We got 10 students who apparently scored in the 80s. Those are your B's. And then how many A's? Students who scored in the 90s.
7.
7 students. Now, just looking at that, do you notice that there's 4 82s? That would be your median, or your mode, excuse me, wouldn't it? 4 82s. That was the most commonly occurring test score. How many 91s were there, class?
3.
3 91s. But for the purposes of a circle graph and a histogram, we don't care about all those numbers specifically. But this is what we care about, class. 2 low F's, 3 high F's or D's, depending on where you are in the country. Here in Georgia, these would be high F's, 8 C's, 10 B's, 7 A's. Now look at the circle graph. Do you see they've already told you that 23% of the students made A's? They've already told you that 27% of the class made a C, and that 7% of the class made low F's, or in their case, F's. They're going off the assumption that D's are the 60 to 69. But they didn't tell you what percent scored D's or B's. But we know that there were how many D's, class? 3 D's. Out of how many total scores? Well, we got to figure that out, don't we? So real quick, if there were 2 F's, 3 D's, 8 C's, 10 B's, and 7 A's, how many total students took this test? 30. 3 D's out of 30 total. What fraction is that, class? 1/10, which as a decimal is 0.1. So what percent should we fill into the little purple section on that circle graph? 10%. There we go. Now the only section left are the B's, and clearly most of the class, or the biggest section of the class, made B's. There were 10 of them. Again, that's 10 out of 30. So what fraction is that? 1/3. What decimal is that? 0.3333, and it just keeps going, right? So approximately, let's cut off to the nearest whole percent. What percent should we put in the circle graph for the B's? 33%. Questions on how to read the stem and leaf plot, then tie it into the circle graph. Does that make sense? Not something we'd exactly done before, but a good opportunity for us. Now for the histogram. The histogram, we're not showing percents. We're going to show that in this classification, in the 50s class, there were 2 students. In the 60s class, 3. In the 70s class, 8. In the 80s class, 10. And in the 90s class, 7. Now they broke one of my rules with this histogram setup. What's one of the rules that they're about to make us break, class?
Touch the top.
Ours is going to touch the top. It's not supposed to, but they only gave you room up to 10. And we know the B's are going to hit 10, so you're going to hit the top of the histogram. That's their fault, not yours. But go ahead and make nice, evenly width bars lined up with those little notches they've given you, separating the classes. And go and finish your histogram here, showing the test scores. Again, we've got 2 F's, so we need to make sure we make a bar that goes up to 2 for the F's. 3 D's, so we need a bar that goes up to 3 for the D's. So if there's 2 of these, we need a bar that goes up to 2. And then if there's 3 of these, we need a bar that goes up to 3 for these. Right? We'll use this pen so you can see the difference and go from there. Good. And just make them nice and equal widths, and as you fill it out, it's very nice, Joel. As you fill them in, shade in the bar a little bit. Try to keep those widths nice and consistent. Looking good, Corey. And again, the histogram just helps us to see how the weights end up going on these grades. See the distribution a little bit. You should get a shape that looks something like that. You get a shape that looks something like this. Showing your 2, 3, 8, 10, 7. And now we can see, man, most of the bars are way up here on the high end, right? These are students who passed, they did well. We see that, hey, a lot of B's and a fair number of A's. This class did well. Yes, there were a few students who had their struggles, but for the most part, the class did a good job on their test. Questions on the histogram, questions on the circle graph, just want to review that with you. Questions on the stem and leaf plot, how to read it. Again, you're not even going to be tested on it. Next year, you'll learn more about it, but not a difficult thing to read, certainly. All right, let's flip back now to page 333. Let's flip back now to page 333, and let's talk about how to actually make a line graph. And there's some instructions at the top of page 333. Well, let's take a look at that little yellow box there. And number one, what's one of the first keys in constructing a line graph, Kirsten?
Deciding on an appropriate scale.
There we go. We actually did this the other day when we were making a histogram. We said, my highest number is 34. I don't want to hit the top. I go to 35, but then I'm going to have grid lines every 5. Let's be lazy. Let's go all the way up to 40. And let's make grid lines every 10, right? So that's what we means by deciding on an appropriate scale. Something that can be subdivided into major and minor grid lines fairly easily. Question?
Can line graphs hit the top?
We don't want any graphs to hit the top. Because again, it just looks like, what if, did you just run out of room, or is that really the top number? So there's no ambiguity when it doesn't hit the top. Great question. Of course, number 2, this is important as well. And kind of, y'all, when you were doing your tri-boards, had the same task. Number 2, Joel. We're at the top of page 333 in the yellow box. We're reading through the steps to constructing a line graph. Make sure you're following along with me. Number 2, Joel.
Give a graph title.
Give the graph a title. Got to come up with a title. You can be clever or you can be boring. Doesn't really matter. Most of the titles on your STEM projects were very clever. Number 3. All right, make sure we keep it straight. Which one goes where, Michael? Number 3.
Label the quantities found in titles as the vertical scale.
All right, the numbers, the quantities, those go along the vertical scale going up. And number 4, we got a big word in here. Okay, Luciana.
Label the chronological sequence as the horizontal scale. The previous chart is labeled chronologically by month.
Yeah, the chronological sequence. What does chronological mean, class?
In order.
Specifically referring to time order, right? Chronological means time order. So since a graph shows progression over time or change over time, in other words, Sam, make sure the time goes across the bottom. All right? So the numbers go up to side, the time goes across the bottom. Number 5, Elaine.
Plot the points on the line graph. For instance, if the sales in June were 27,000, go across to June and up to 27,000. Plot 1 point to represent both facts.
There we go. And then, of course, number 6, Corey.
After all the points are plotted, connect the points to form a line which may be curved, broken, or straight.
There we go. And for our purposes, again, we're going to be going with the broken lines. So let's do a couple of these together, shall we? Turn over to page 335. Now, they've already done a lot of the work for you here, okay? It kind of spoiled you just a little bit. As we look at number 11, do you see they've already come up with your title? They went with a boring one, class. What is the title for number 11? Sandwiches per day. And they've already come up with your scale. They decided to go as high as what, class? 45. But notice, they didn't have to start at 0, did they? They only went as low as 20. All right, so they decided every 5 they'd have a major grid line, and they put a minor grid line for every single data value. Do I like putting grid lines for every single data value? Because I am lazy. But hey, if they're going to computer generate it, I mean, why not? It makes it easier for us now, so they did it. So, whatever. Across the bottom, they have what? Ben?
The axis title.
Well, they have an axis title as well, but so what is the axis title? What did they put across the bottom, the horizontal labels?
Days of the week.
The days of the week, Monday, Tuesday, Wednesday, Thursday, Friday. I guess they're not open on weekends. And then up the side, we have our scale telling us what, Kirsten?
Number of sandwiches.
The number of sandwiches running vertically. All right, so what we need to do is Monday. How many sandwiches did this place sell, class? 34. So you need to go up above Monday and go straight up above it very neatly and carefully and put a dot on the line for 34. Then put your pencil at Tuesday and go straight up directly above it until you get to 28. Just a couple lines below 30. Put a dot there. So Monday, we have our dot at 34. Okay, so 35's line is here. It's one grid line lower, okay? And then Tuesday, we're down here at 30 and we go 2 grid lines lower for Tuesday. What about Wednesday, class? Put a dot at? 27. So we go over to Wednesday. We go straight up. We put a dot at 27. Then for Thursday, we go straight. Thursday goes straight up to
To 32.
32, so we're going to go a couple grid lines above the 30 and to the 32. And then finally Friday, go straight up to
35.
35 to the major grid line. And then just connect with nice straight lines as you go. If you happen to have a ruler, you could use that, though I don't think you're drawing very long lines. I don't know that you need a ruler to connect those dots. And let's see how we did. All right, so make sure Monday stays directly above Monday. Tuesday directly above Tuesday. Wednesday over Wednesday. Thursday should be over here above Thursday. And Friday directly over Friday. Does that make sense? So make sure we stay above the appropriate marks. All right, we don't have to draw a line to the starting point, right? We don't start at 0. We just start with Monday. So we don't draw a line to the first dot. We only draw a line from the first dot. All right, now we're doing a line graph. So that means what we needed to do here was put above Monday, put a dot. And above Tuesday, a dot. And above Wednesday, the dot. And then we're going to connect with the line. Okay? So we'll do better on the next one. All right. Good. Yeah, so again, we don't need that first line. We're going to actually start here with the Monday. Okay? And good. All right, now, look at the next graph. If you had some trouble on the first one, most of you did fine. Some of you had a little trouble. That's okay. That's why we're here in school. We're here to learn. If we already knew everything, there'd be no point. So it's okay. We come to learn. I want you to do the same thing now with the phone calls per hour. It goes through telling how many phone calls this customer service supervisor observed throughout the day. So again, find the time, put the dot in the correct spot, and then connect those dots. Number 12 at your seats. Stay directly above those marks to make the graph nice and easy to read. What's the value of each minor grid line, class?
5.
5. Each minor grid line is worth 5. So we may have to go between the grid lines a little bit here. Looks good. Oh, we just didn't finish new.
Oh,
There we go. That's why. Okay, I was like, something seems off. That's why I just didn't get to new yet. All right, good. Looks good. Okay, so it was really only this this one value. It was just a little bit off, but otherwise good. Now, you took a little dip for some reason. Why did you dip down? Remember, just nice straight lines between the points. Good. Yeah, you scribbled it out. Good, good. A nice straight line going straight up. There we go. All right. Turn over now, if you would, to page 337. Turn over to page 337. Let's do this homework problem that we skipped. Read number 6 on the homework section. Michael.
Construct a line graph with the given data.
And go and read the data for us. What are we doing here? Or what are we tracking here?
A number of tropical cyclones.
In a given year. So, in 2009, there were 9 tropical cyclones. That means hurricanes, okay? Or tropical storms, any type of tropical swirling wind that gets a name. So 9 tropical cyclones in 2009. Then in 2010?
19.
In 2011?
19.
2012?
19.
Wow, there's your mode. 2013?
14.
2014?
18. Wait.
Just 8.
8, okay.
And then 2015? 11. So there was a few really rough years of lots and lots of storms that it kind of dipped down. So go ahead and on your paper, let's go ahead and draw a box that can represent our graphing area. And what do you suppose we should use as a title? Volunteer to give us a good title. Kirsten?
Number of advanced tropical cyclones.
Or maybe I won't even say number of, I'll just say Atlantic tropical cyclones. Atlantic tropical cyclones. Now my biggest number, class, is what?
19.
19. So I should make sure my graph goes to at least 20. Right, because we don't want to hit the top of the graph. And 20 is a nice, easy number, right? I don't even need to change that. So let's let 20 be the top of our graph. Now, remember, it's not a bar graph. It's not a histogram. It doesn't have to start at 0. What's my smallest number, class?
9.
8 is actually the smallest number. Huh, you know, for that matter, I don't know that it'd be that bad to start at 0, honestly. Though we could, if we wanted to, maybe start at something smaller than 8.
4.
Does 6 subdivide easily with 20? But 5 does. Let's make it start at 5. Let's make it start at 5. Now, if that's the case, then our major grid lines should be every 5. So we've got 5. We're going to want 10, 15, and then 20 at the top. So that means we need 2 more grid lines. So let's try to space out a couple of grid lines that are approximately evenly spaced with between the 5 and the 20. And we'll call these 10 and 15. Now, the only downside of doing this is that's a really big space, right? 5, a gap of 5. So are we going to need some minor grid lines?
Yeah.
Probably. Now, this is where it's hard. If there's a gap of 5, how many actual tick marks do I need?
4.
I need 4 tick marks. So trying to space out 4 tick marks is hard. I'm not going to draw the lines yet. I'm just going to make the tick marks. 4 little tick marks, just to see where they're evenly spaced. And I might do the same thing on the other side. Try to space out 4 even tick marks. And then, bless you, I might actually run the lines between them. Just a little bit lighter. We're not going to actually number these. It would help to have blue lines on the paper, bless you again. She's allergic to line graphs. And we can do the same for the others, right? Subdivide into 4 parts, 4 tick marks. Well, 5 parts, 4 tick marks. And then try to connect those lines together. We're thankful that computers can auto-generate these for us most of the time. But even hand drawing, and we can do a decent job. See, my line has a little scoliosis going here. Didn't turn out too great. 2, 3, 4 lines. Those are relatively evenly spaced. It's almost like a football field, except we are drawing between the hash marks. And nobody's getting concussions. All right. So we've got our Atlantic tropical cyclones. We've got our, now what do these numbers refer to, class? Is this how strong they are? Is this the mile per hour winds? No, what are these numbers here? Number of storms. So on the side, let's give ourselves a vertical axis title, number of storms. We'll go up the side with it. And then across the bottom, we need to put what, class?
Years.
The years. And that should be our label or axis title as well. Years. Now, how many years are we going to have to show on this chart, Michael?
7.
7. Now, our first year should probably not be at the very beginning, right? Because this isn't the start of all things. There were years before this. So come in a little bit, make a little notch, and we can just write 07 because we're lazy. That was our first year that we're... Oh, 09, I'm blind. 09. Sorry. 7 years, that's where I got this. I said, where did I get 7 from? There are 7 different years we're going to show. So 9, 10, 11, 12, 13, 14, 15, and 16? It stopped at 15. Okay. Oh man, look at this. I got all this empty space at the end. Well, I could draw my line down here and then erase that end. Or I could just leave it. I'm just going to leave it. So we got our different years in there. 9, 10, 11, 12, 13, 14, and 15. Were any of you alive in 2009?
No.
A couple of you. Okay, a couple of you born in, or alive at least in 09. All right, so I'm going to switch to a different writing utensil now, just so it shows up a little bit better. Maybe you could do the same if you've been setting it up with pencil. Maybe get a pen out or a highlighter or something. Our first dot needs to go above 09, and that number, class, is?
9.
So we're going to go one grid line below the 10, put a nice dark dot there. All right, then above the 10, class, we're going to put?
19.
19. Oh boy. So that's one grid line shy of the top. And we might as well get comfy up there because for 2011,
No, 19.
19. And then in 2012,
19.
another 19. And then finally 2013, it drops off a bit.
18.
14. And then in 2014,
8.
just 8. And then in 2015,
11.
back up above, back into the double digits with 11. And so we'll connect with a nice straight line. It's really easy to get a straight line between those ones. And get a graph that looks something like this. Questions on how to make a line graph? Any questions on how to make a line graph? Because after all, being able to make one helps you understand it better. Makes it even easier to read a line graph once you understand how to draw one. Any questions on that? All right, come around and take a look at those, see how they turned out. Not shabby, not shabby. Very nice. Very nice. Finishing up some things there. Just connect the dots and we'll not worry about all those extra minor grid lines at this point there. Ish, plus or minus.
I tried.
Very ish. Yeah, you tried to go ahead of me there instead of staying with me. That didn't help. All right, turn over to page 340. Flip all the way over to page 340. And speaking of storms, let's go from storms over water to storms over land, some tornadoes. In the United States, 2015, there's your chart title. And they have what type of graph here, class? Histogram, a histogram. Now, do you notice how they break down the wind speed in miles per hour? And you guys might recall, you studied tornadoes earlier this year in Earth and Space Science, didn't you? And so an EF0 tornado has winds between 65 and 86 miles an hour. If winds are between 86 and 111 miles per hour, it's EF1. Between 111 and 136 is EF2. 136 to 166, EF3. You got your EF4s up to 200. Anything over 200 miles an hour is EF5. Does anyone remember what the EF stands for?
Oh. Okay. Enhanced Vegeta scale?
The Enhanced Vegeta scale. There we go. So that's what the EF stands for. Good job, you guys. And by the way, if you're watching on YouTube and like, I'm taking life science this year, our school combines junior high, 7th and 8th grade science into one group. So we alternate what we do each year. This year we're doing the 8th grade Earth and Space Science as a group. So they're doing the other, they'll take life science next year. So if you haven't learned it, you're like, how come I didn't learn it? They're doing the 8th grade science this year. They're just that smart. All right, so anyway, which class had the most tornadoes in the U.S. back in 2015? Bryson?
It was.
We're down here. The histogram. Which class of tornadoes which class had the most tornadoes in 2015?
Oh, EFO.
The EF0, right? The 65 to 86 mile an hour wind tornadoes. Which class had no tornadoes in 2015? There were none of these, Joel.
EF5.
The EF5. There were no 200 to 300 mile an hour wind tornadoes, which has got to be a blessing. Who needs those? How many more tornadoes were recorded as EF2? That's your 111 to 136 mile an hour winds versus EF3. About how many more tornadoes? Well, how many EF2s were there, class?
700?
Wait,
EF2. How many EF2 tornadoes were there?
66?
A touch over 60. Do you see that the grid lines are each 20? Do you see that? The major grid lines are 100, so the minor grid lines are 20, and so the EF2 goes up 1, 2, 3, and a piece. So maybe it's more like 65-ish, maybe something like that. What about the EF3? How many EF3 tornadoes were there?
19.
20, just 20 EF3s, right? It's one grid line up is all it went. So probably about 20 EF3 tornadoes. So how many more EF2s than EF3s?
45.
About 40, 45-ish. We've got to be over 40, so maybe close to 45. Okay, something like that. Oh man, total tornadoes. Well, we already know EF2, we said there's 65. We said EF3, there's 20. How many EF4s?
10?
Not even. It doesn't even go halfway up. Maybe 5 EF4s? Something like that. Now, EF1s, how many EF1s were there?
65?
Just a touch under 400. I mean, you could almost just round and say 400, honestly. It's pretty much touching that line. Maybe like 395 or something like that. But we say 400. How many EF0s?
699.
Yeah, that one actually really does go up to the line. I'd say 700 there. Let's use easy numbers because we're lazy, right? So let's say we had 700 EF0s, 400 EF1s, and then it drops way down. Like the really strong tornadoes, not many of them. We said there were 65, 20, and like 5. If we add them all together, how many of these tornadoes were there?
1,100.
About, and again, this is an approximation, but about 1,190, close to 1,200 of these tornadoes. How many tornadoes reached at least 111 miles per hour? How many tornadoes at least 111 mile per hour sustained winds? Elaine?
There's 20 EF3.
Right.
Yeah, 20. And then plus 5, 25.
Well, those are the ones that were over 136, right? Your EF3s and EF4s were over 136. They wanted what's over 111.
And then EF2 60, so that would be 85.
Yeah, it's more like 65. So somewhere around, it's 85 to 90, though. Somewhere give or take there. Again, that's approximate, but 85 to 90 of those tornadoes. Were there more EF0s or all the other scales combined? Were there more EF0s or all the other scales combined?
More.
The EF0s, the 700 is more than all these other ones put together. So in other words, if a tornado happens, the probability is really good that it probably is EF0. Most of them, literally over half of them, EF0. So that's where the mean, median, mode would all lie. Questions on the tornadoes and a histogram. All right, look across the page now at the line graph, excuse me. Let's look at the line graph here, and what are we talking about in this line graph for 54 to 59? What's being discussed here, Jalen?
The 20th century population of Ohio.
All right, so by the way, what is the 20th century? What was the 20th century?
1990.
The 1900s were the 20th century. And so we are now in the 21st century, but the 20th century would have been the 1900s. All right, according to the chart, did Ohio's population ever decrease in a 10-year period? No, it held steady from two decades, 3 groups of years, I guess.
193 to 194. I mean, 1920, 1930, 1940.
It actually clearly went up. Not much, but it did clearly go up 1930, 1940. There's a period where it held almost perfectly steady, though. 1970 to 1990. Look at that. Do you see how the graph almost stays perfectly horizontal right there? No real increase at all from 1970 to 1990. But was there ever a decrease, class? No. All right, so there's our answer for 54. How about 55? How many years did it take the population to double from 1900? Well, let's start at 1900, class. Starting in 1900, about what was that population? Joel?
4.5 million.
Yeah, a touch over 4 million, right? Let's see. What is each minor grid line here? Goodness.
Million? I mean, 200,000?
It's let's just say it's a touch over 4 million. Let's be lazy, all right? We're approximating everything anyway. So a touch over 4 million in 1900. So doubled would be when it finally goes, class, a touch over 8 mil. When did it finally go a touch over or right about 8 mil? 1950. So that means it took how many years to double?
50.
About 50 years. From 1900 to 1950, it took about 50 years for that population to double. By what year, or in what year, did Ohio finally have a population of around 10 million people? Ben?
1960.
Yeah, 1960, it's really close to 10 mil. It's a touch under, but it's really close to 10 mil in 1960. Which decade did the population jump the most? Which of those decades did we see the biggest climb? When they did the census in 1 year, 10 years later did another census, like, man, there's a whole lot more people all of a sudden. What decade was that where the big jump happened, Kirsten?
1950 to 1960.
Yeah, the 50 to 60 jump was the biggest, sharpest jump. There was growth steady pretty much throughout, but yeah, 1950 to 1960, big growth in the population there. What decade saw the smallest growth in population? What decade did we have the least growth? And I could argue there's 2 decades where we saw the least growth. Class?
1970 to 1980.
Yeah, the 70s and 80s, right? Virtually no growth. Now, does that mean that there were a lot of people moving out of Ohio? Why was I don't know. What about 1940? How many people in Ohio? About how many people in 1940? Corey?
6 mil.
Well, definitely more than 6 mil, but it's not quite halfway up to the 7 mil either, is it? Or to the 8 mil, is it? So, but it's close, right? Like, do you all see, by the way, that where 7 million doesn't get a line? Those make this graph really weird. It's poorly drawn. There should be a line for 7 somewhere, one of the grid lines, surely, but no. They didn't give you a 7 grid line. 7's grid line is actually the space above that dot. Do you see that? So it's really close to 7 mil, Corey. So maybe we guesstimate
Like 6,900,000.
6,900,000 or 6.9 million, 6.8 million, something like that. Yeah, 6.8, 6.9 million people, something like that in 1940. I don't like the way their grid lines turned out, but whatever. They didn't ask me about it. Questions on reading line graphs. Questions on reading line graphs. Hey, how about the last 2 graphs we've been working on a lot lately, the histograms, the line graphs? Do we feel like we understand those fairly well? All right, clear desks, except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Let's take a quiz over histograms and line graphs. Let's take a quiz over histograms and line graphs. As we work toward wrapping up this section now on graphing. Clean sheet of paper and a pencil. For those watching on YouTube, this is quiz 33. So we are skipping over quiz 32 since we skipped over all the stuff that was on quiz 32. The stem and leaf plots, the box and whisker plots. We skipped over all that. So we're also skipping quiz 32. We're going straight to quiz 33 here today. Pencil, paper, everything else away. When you get your quiz, put your first and last name in the name spot. And today's date in the date spot. There we go. And today is 4/24/24. 42424. Or if you go backwards, it's 42424. Anyway, sorry. First and last name, 4/24/24, today's date. Really straightforward quiz. You got a histogram, you answer the questions about it. And then you got another graph down there, you answer the questions about that. 5 questions about each graph. All right, use the blank page as a cover sheet to cover your answers best you can. And you may begin. There will be no homework this evening, so I'll go ahead and end the video here.